Welcome to Peoples and Things, where we explore human life with technology. I'm Lee Vinsel. Brothers and sisters of the P&T, how's it going? What is the best road into this episode? I've been asking myself that for a while now. And, well, here's one. It seems to me that it has long been the case that a central line of thinking in science and technology studies centers on criticism of what is known variously as solutionism or the technological fix and other names. Here's one definition of solutionism. It's the idea that given the right code, algorithms, and robots, technology can solve all of mankind's problems, effectively making life frictionless and trouble-free. For a while now, and probably ever increasingly so, I have been wondering about this line of criticism. It seems to me there are two basic problems. First, the idea of solutionism is conceptually unclear. It's so unclear that you can almost be driven to wishing that an analytic philosopher would come along and write an essay doing conceptual analysis and laying out what solutionism could and should mean. And that's really a dreadful place to feel like you're in, because analytic philosophers are miserable, unfun people who you never want to invite to parties or even share a meal with, frankly. They are a real drag. So saying you feel like you need help from one is really saying something. It means you're in a bad spot. But the second problem is even bigger. Even when I feel like I can get my head around what solutionism might mean and why it might be a problem, I look around at the many problems in this world and I'm like, solutionism is causing these issues or leading to them not being resolved? For reals? If we look at economic hardship and poverty around the United States, for example, and we look at places like Flint, Michigan, rural West Virginia, my hometown of Joliet, Illinois, homeless camps throughout the American West, especially California, the south side of Chicago, and a blown out former textile and furniture manufacturing town, Pulaski, Virginia, which lies about 25 miles down the road from my current home in Appalachia. If we look at these places and we ask, how much is solutionism to blame for the material problems and human pain and suffering in these places? I mean, let's be real, folks. I'm having a hard time seeing it. Also, is it not true that technology and shifts in medical practices solve problems? I don't know, when was the last time there was a cholera outbreak in the United States? Or when people would assume that Andy Russell and I were somehow opposed to technological change because of the kinds of criticisms we'd make about certain ways of thinking about technology when we were working on the maintainers, we'd be like, I don't know, I'm pretty happy to have dental anesthetics and antibiotics. I don't know about you. Or consider how something like 80% of poor households in the United States have air conditioning today. It's not because we made welfare that much more generous, it's because of how cheap things have gotten. Or think about how many women and babies used to die during childbirth. I've heard arguments that the cesarean section, something that we see as ordinary and totally take for granted, is the most life-saving medical procedure in history. Or think about the second episode of Peoples and Things, where I interviewed the activist Catherine Coleman Flowers, who is maybe my greatest living hero, about the lack of septic tanks in rural communities. In Flowers' case, particularly poor Black communities in rural Alabama, and how so-called tropical diseases like hookworm have returned in some communities because people are coming into contact with raw sewage. Now, if I remember correctly, Flowers told me that some of the engineered septic systems you need in Alabama cost as much as $40,000 to install. But now imagine that you could get the cost below $10,000. That's never going to happen, which is why we should also consider alternatives. But just imagine it for a moment. That would solve real problems, including diseases our fellow citizens are facing. Now, is it that we want to say something like, well, you can't solve social problems through the technological fix? I feel like maybe even I've said something like that before, maybe even in the innovation delusion. And we can certainly find ridiculous examples of like listicles saying, here's the top 10 apps to end poverty, or the top 10 apps to end racism, or whatever. And that's just silly, just ridiculous. But I mean, we can talk about peoples and things in their relationship because there are things that we call people, and then there are things we call things. And if you point at one of my friends and say, hey, look at this thing right here, I will think that depending on the context, you are either being funny or you're being an asshole. But I really don't think we want to say that on the one hand, there is society and social problems, and on the other hand, there is technologies and technical problems. No, that just creates mental fog and gets us into trouble because what we call human society is made up of beings who use all kinds of tools to go about their business. So I don't know. It's all extremely murky and I'm losing hope over here. Oh my God, life. And here's another issue with the critique of solutionism. How should engineers think about all this? Like, engineers build systems and solve problems that have been specified by their clients, right? How should they shift their thinking to bring in the kinds of social and technical complexities that undergird real-world problems? I mean, it's cool for us non-engineers to be critical. Oh, it's so critical. I'm so critical. But engineers have to continue working. So what should they do? Well, that's one way to think about today's guest, Guru Madhavan's new book, Wicked Problems, How to Engineer a Better World. Guru's an interesting guy. I first met him through Maintainersy Worlds. He's the Norman R. Augustine Senior Scholar and Senior Director of Programs at the National Academy of Engineering, where he works on a variety of engineering policy and education initiatives. Guru is interesting because he takes history, philosophy, STS, and lots of other work in the humanities and social sciences seriously, and he's clearly learned a lot from them. But he also wants to ask, how do engineers reframe their work in the light of all this learning? And I think he has a neat and exciting answers to that question. I always enjoy the time I get to spend with my buddy Guru, and I had a lot of fun with him in this interview, as you'll see. Hey! Get excited! Guru, thanks so much for taking the time to talk to me today.
Lee, it's a joy to be on, and thanks to the listeners as well.
So Wicked Problems is a neat book. When you talk to strangers about it, what do you tell them it's about? What were you trying to do with it?
Well, let's pretend that stranger was you, Lee.
Yeah.
And I would say that the book is all about people and things and all the problems that come from them and what to do about them. So the book articulates an engineering sensibility, specifically a systems engineering consciousness, to kind of make sense of the world. Of course, we have had a lot of foundational principles, guiding processes from sciences and philosophy and so forth. But engineering, let's say, as an intellectual foundation, as an act of know-how, consciously embraced by the culture, which is far older than the act of know what, I think can provide a better guidance because of the ability to engage with the consequences that is innately part of the act of creation. So it's an ode to systems engineers, or stated in a more expensive way, a homage to the systems engineering consciousness, to kind of engage with the inner nature of the problems.
Your book, now I'm going to put down engineers for a second. Your book does not read like it was written by an engineer. It's very beautifully written, man. You've really developed a nice prose style. So I really want to just kind of tip my hat to you. It flows really well. There's some great sentences in there. So, good work, man.
No, you haven't read my technical articles, by the way. So
I know. I was going to ask if you had a good editor.
I write for 3 people who would basically pass the article to get it published. Eventually, that gets read by maybe a dozen people.
You and me both. You and me both. So I wanted to. How'd you come to write this book? I mean, you did an earlier book on like how to think. How engineers think, and how what led you to write this more recent one on wicked problems.
The first one was somewhat bombastically titled Applied Minds, How Engineers Think.
Mm-hmm.
Whereas this book, I've taken many years between that creation and this, almost an inherent agenda there, how engineers should think about the world. And in a way, what does it mean to be an engineer in the modern world is the the broader philosophical construct. I touch and go on those themes as one proceeds with the book. But the thought that was embedded in me since get-go, since I was in high school trying to get into engineering, was engineers are problem solvers. Mm-hmm. That is the dominant attribute, mm-hmm. characteristics, or even a marketing point mm-hmm. Assigned to engineers. Made me think about it. And of course, in my own internal analysis, I know that I'm good at solving certain kinds of problems with defined objectives, with defined outcomes, mm-hmm. and whatnot. But the world that I have found, especially having lived in Washington, D.C. for 15 years, is you don't quite engage with the problems in a way, because increasingly the problems seem insoluble in a way. So how do you make sense of that? So the way I wanted to pursue this book was in the form of a detective quest originally. An engineer trying to solve problems that don't have solutions, mm-hmm. had a good, neat hook to it. Of course, the publisher bought it. And of course, what I delivered to them was completely different. And I'm very grateful to have a very sympathetic publisher here who let me go on this journey of discovery of self. I mean, how problems occur in the world that we inhabit, what we do to them, mm-hmm. what they do to us. So that, I think, was the the guiding light. And I tried to develop this book. The structure itself took some time to come together. It's a 2-track book. When I talked about systems engineering consciousness early on, that specifically means how do you develop what in the trade we call a concept of operation? How do you make sense? It's a a narrative about the world that doesn't quite exist.
Yeah.
So the ideal attributes that one brings into, whether it's a design process or a production process or manufacturing a system. So that is something systems engineers take very seriously. Concept development is the heartbeat of systems engineering.
And this is this is part of the tradition. This is how not just you, but this is how the tradition talks about it. Is that right?
That's correct.
Okay.
And we try not to, and this is incorporated early on, as well as some of my colleagues in the systems engineering community like to say, we focus on pre-work, not rework. Mm-hmm. And that often gets lost, especially in the world of public policy, where you're trying to provide engineering input or advice or recommendations on how do you create a world based on the technologies that are available to us, based on the historical precedents that have been made available to us through experience, mm-hmm. And social choices. And how do we go forward with it? So a systems engineer is playing with, is dealing with, is applying their convening mindset rather than a controlling mindset. Mm-hmm. My basic training was in systems engineering of a different kind, with an emphasis on control systems, with instrumentation, transducers, and all sorts
feedback
of things where you
machines and stuff. Yeah,
where you're dealing with extremely complex processes, mm-hmm. with whether it's a chemical factory or a fertilizer factory
Yeah.
or a pharmaceutical production, whatnot. So there are those types of activities that made me realize that, okay, there are problems that are entirely solvable. But when you move from a control system sensibility to a complex system sensibility, I think your worldview changes. And you can bring some of those aspects that you learned in control theory into complex systems, but they quickly stop making sense after a particular level. And now I think the idea of brute force applying control theory concepts into a complex systems concept can have pernicious consequences, as we all know. And we have learned about it extensively, but we don't know what to do about when it comes to making more conscious, responsible choices in the kinds, plural, kinds of engineering we ought to be doing for public welfare.
Yeah.
That's a ill-explored question in engineering, and that's where scholars such as yourself and others, historians, even archaeologists, are providing insights into how we need to be thinking about it. I've been hanging out with the evolutionary biologists lately extensively, and they present a worldview that is deeply appealing to me as a systems engineer, because I feel like it's largely sympathetic to the kind of, how do you understand vulnerabilities in a system, whether it's a body or a machine, right? I mean, so of course one can overlay the standard engineering control system concept into, this is how the liver works, this is how the pancreas works, and this is what happens when they don't work. That takes me so far. I can come up with a nice paper or a PowerPoint slide, but I think what do you do with the other consequences that are attached to it? I mean, how do you pay for the prescription drugs for this maladaptive disorder that we're dealing with? Or how do you prevent those conditions in the first place? Very different set of consequences. So I have gotten in the mode of understanding systems engineering as a cultural sensibility. And I'm even thinking, and I don't have, of course, this is very difficult to argue here, intuitively, let's say, perhaps systems engineering was the original engineering sensibility before we became super specialized to the point of, we don't even recognize engineering. Anyway, we have so many different types, denominations here. So was systems engineering the original sensibility, the way we built civilizations? I mean, we were all tool builders even before we were discoverers or poets. So I think starting that as the authentic initial cultural choice helps drive my thinking on these kinds of subjects forward.
I was going to ask you about this, the concept of operations a bit, because it really, you had a paragraph on it in the introduction that just really stood out to me. And in one place you say, so concept of operations is can be abbreviated ConOps. And you say, in other words, ConOps are narratives about a situation we haven't necessarily experienced. And I was wondering, I mean, like, is this you? I mean, is this your take on it? Or is this, have others been talking about it this way? Because it just strikes me as like, whoa, systems engineers and humanities professors are going to start hanging out and talking about narrative and, how we use these things and how they shape our world. I just wondered, like, how much of this is like your reworking of the systems engineering tradition versus how much of this is like already been around?
If I showed you a ConOp document that I developed when I was working in the medical device industry, you and I wouldn't even be having this conversation. I probably wouldn't have even come into your cosmos. Oh, by the way, it is deadening, highly compliance-oriented. What happens in the assembly and the R&D lab versus what happens in the clean room with this. It's quite different, and that's mainly because where this idea of ConOps has been rigorously and profitably applied, has been in extremely regulated, safety critical environments.
Right.
Now, if you expand that idea of safety criticality, pretty much every decision we do in society affects one another in some way or another. So I think that is translatable. So that's why I've tried to rework the ConOps for cultural use, so to speak. But the ConOps, as I've argued in this book, and as they were originally intended, are about how a system would work, what functions it could responsibly fulfill,
right,
and what outcomes it should achieve. So that is applicable whether you're welding a joint
Mm-hmm.
or you're trying to unify a political discourse on
Mm-hmm.
a controversial subject for society.
Yeah, I hear you. Before we dive more into the book, I wanted to ask you kind of like give, to give people kind of sense of your trajectory as professionally. So, you have this cool job at the National Academy of Engineering and you're writing these books. I've been thinking about you as Guru, the engineering guru for a while, whether you like it or not. So I just wondered how, like, well, you got you're a SUNY grad, is that right? You got your multiple degrees at SUNY, and then how'd you kind of get into this professional, position you're in?
Well, to add more gravitas to the word guru here, it's of course from Sanskrit. Gu means darkness, and ru means the dispeller of. So the remover of darkness, bringer of enlightenment.
Yeah.
And one of my college professors, an electrical engineer, like to call me light bulb. So, which kind of takes us to my own upbringing. I was born in a Orthodox Hindu family back in India, and that's where I did my undergrad in control systems. Trained as a junior engineer in multiple industries, and that led me to, um, you know, decide on biomedical instrumentation as my preferred career path. And fortunately, the State University of New York decided to take risk on me, and they gave me a scholarship to pursue a PhD degree in this country. And I came to the United States a month before 9/11, as the country itself changed. So I've, in a way, grown with this culture and extremely grateful. And after my master's in biomedical engineering, I worked in the medical device industry, worked on a cardiovascular ablation technology to eliminate atrial fibrillation, a cardiac rhythm disorder, which left untreated could create a whole lot of problems, including stroke.
Yeah.
And affects a fairly large set of population. And that company got acquired by a bigger company, which got acquired by one of the biggest companies right now. And that gave me kind of the professional experience to really think about. When I mean that, I specifically said I've seen three hearts stop right in front of my eyes. And I was in my 20s trying to make sense of the world and understand the difference between life and death. And I was more idealistic. And so, how do you prevent these conditions from occurring? So, those experiences led me to go from a more therapeutic, corrective, surgical approaches to preventative approach. So, again, one type of problem, the way you solve problems in surgery is pretty direct. Blood, sweat, and tears, literally, in this case. And now, how do you prevent that? And that takes you into the realm of human behavior, incentives, and all sorts of things that economists have written about all these decades. And but as I was pursuing that transition, and this is where I moved from Stony Brook to Binghamton, New York, which had a very different outlook to design and the work. And I got to learn from nurses who had a very different perspective on health. And Binghamton didn't have a medical school, unlike Stony Brook. And I'm extremely fortunate to have both these kind of trajectories to drive my thinking here. It's the idea of you don't build a bridge for 3 years, you build it for much longer. And I think nurses instilled in me that sensibility. I think when talking about long-term thinking in a pretty direct way, it's nurses and how they thought about caring for people, whether healthy or those who need care. I think that was a profound education for me, learning from doctors versus learning from nurses. And that, of course, I think in a way got me very interested in the concepts of care and maintenance several years ago. That still guides my thinking in many realms. And I was going to start a medical device company as a result of my work, which had now migrated to the realm of neuromuscular stimulators, so improving blood circulation from lower extremities, and that could have significant clinical implications in conditions like osteoporosis, even neurological illnesses, and so forth. And I also did a business degree along with my PhD.
Yeah.
Because that was something that was directly helpful for my planned goal. But then the global economy crashed in 2008, and I was a freshly minted MBA, and nothing at all of any signal or even a discussion came about in my entire business school discussion. And I think a lot of business schools went through that reflection, and a lot of business school graduates went through that reflection to the point that I felt empty, even dishonest perhaps at that moment. And then I semi-randomly applied for an economic policy fellowship at the National Academies, which I now call my intellectual home, during the peak of the economic crisis. And lo and behold, they selected me. And I was then a fellow working for a former Treasury Secretary, a very influential one, during the peak of the financial crisis. So that was extremely informative, because I was the only engineer among the economic legends of the day, trying to see how they made sense of the world. And what really was impressive was, under those conditions and under those demanding situations, they had viewpoints that seemed palatable, understandable, marketable. And I think we have all seen through what has happened over the past several years, and what does it take to revive an economy, in this case, a set of economies interconnected, and how large institutions can go down in a blink, while evaporating hundreds of thousands of jobs and bank accounts at once. So you can see some of the work that happens. But if you look back at it, engineering and engineers have had little to contribute to that conversation, in a way. And I often wondered why. Then I realized very few engineers do this kind of work in the first place. So then I was offered a full-time position at the National Academies after the fellowship. And then I found myself at the centroid of the triangle: government, business, and academia. So the centroid effectively allows me to mix all these things, and also focus on international engagement and broad public engagement, which has led me to kind of articulate these complex ideas perhaps through narrative means, short form articles, long form articles, and so forth. So it's become a kind of a unique path for me in what could have been an utterly traditional route.
Well, and wildly productive too, man. You write so much, and it's good. So it's not like the the output, high output, is not ruining quality. Thankfully, it's great stuff. So tell us, what's a wicked problem? So is it a naughty problem that needs to be punished, and how do we think about wicked problems, and what does this concept do for you?
Before we get to the wicked problems, let's go back several more decades in the past. The philosopher Karl Popper, he tried to make sense of the world using the notions of clocks and clouds. Clocks are well-defined, well-behaved systems with utterly predictable properties, and you can name what they are, whether it's a wristwatch or if it's a jumbo jet. You can, and I think engineers typically have flourished in those domains. And the other side of the spectrum here is the idea of a cloudy system, which is defiant to logic, doesn't obey any rules, has a lot of interactions, and disagreements are just default. So that's the kind of the spectrum that he put. The wicked problems, as I've tried to make sense of it from Karl Popper's perspective, are the cloudiest ones, where the problem is not necessarily groupthink, where people have a fixed idea, which often happens, let's say, in a defined engineering product or a system, and then you go forth and deliver it. But the exact opposite, what John Warfield, an electrical engineer, called it a spread thing, where people can't even agree on the basics of the problem. And now that is something we're experiencing day in and day out here. So the cloudiest of the problems or the wicked problems, but in a more modern sense, in fact, 50 years ago, the term wicked problem was coined by two people, Horst Ritter and Melvin Weber, who wrote a very compelling paper. It was in a policy journal where they articulated about 10 properties that that kind of characterized a wicked problem. And they included, like, they had no clear definition, and we don't know where they start, where they end, and the solutions aren't necessarily right or wrong, but consequentially whether they're better or worse. And worse, if you have a technical fix or a one-shot solution for it, consequences are definite.
Yeah.
And usually worse. And each of them is unique, which means there is no set pattern to it. There is no formula or a clear-cut formulation. Now, this takes, all these things are completely foreign for most engineers, as we are trained even now. And that's why I worked on this book. What does it mean to be an engineer in a complex world and deal with these kinds of wickedness? And the wickedness also is a function of the worldview. Of course, the famous engineering worldview of doing X, Y, and Z in a specific fashion or in exact order gets uprooted. It makes no sense at all. And even the idea of what's right, what's wrong, what's truth has very fuzzy barriers. So that's what I think they tried to articulate in that paper 50 years ago, almost. It was published in 1973. And now we have a range of problems around us that are immediately identifiable as wicked problems, whether it's democracy or climate or economy, or how do we treat people who are displaced. The problems of homelessness have remained for decades. So how do you deal with it? To approach a wicked problem, the way I approached in this book was to understand its composition. And for that, I deeply relied on the work of Russ Ackoff, the systems theorist, who has influenced my thinking over many years, the late Russ Ackoff. My formulation was there are problems that have very defined boundaries, which are the exact opposite, almost like the clock systems I talked about earlier. And there are those boundaries and the requirements, so to speak, are provided by the market or the consumers or sponsors. And we know what to do under those conditions. And those conditions can lead to a solution. Literally, those hard problems can be solved. But then there are problems where human behavior complicates them. For example, building a car is a hard problem, but managing a traffic is a soft problem, because there are many different goals and even why people drive or choose to take one mode of transportation or other, why some cities are built in certain ways and not the other, whatnot. So that's what I've called in this book as a soft problem. Soft meaning not softer than hard, but I think harder than hard. And how do you do this? And you cannot really cut them down into pieces, tame them to yield a single point fixed formula solution per se. So you can't really solve a soft problem. You can only resolve them, as Ackoff called it, you satisfies them. So you can optimize them to a particular level, but you can never hit it. So you can manage it. But when you combine the hard and the soft problem, you bring in you add some doses of the value systems and ideologies and other beliefs and political variables, you have something called a messy problem. And so, as slated, each of them are unique on their own, but they have interactions with them. A soft problem can be composed of multiple hard problems, but you can still never reach a acceptable solution. Similarly, hard and soft interact to produce messiness, and messiness can be composed of both and hard. So you can see it's like a Russian doll, and so the hard problems and the soft problems and the messy problems interact to produce wickedness. Unlike hard problem and unlike a soft problem, you cannot solve or resolve a messy problem. You can only dissolve it, which means you have to transform it into a very different format for you to even engage with it. A tool that was taught to me when I was in high school and as an engineering student, when I routinely used it, was the idea of Fourier transform, a mathematical tool to make sense of the data that's in front of you. How do you derive a meaning out of it? And that was often the problem that I had when I was collecting real-time physiologic data when I was doing my doctoral work and so forth. So FFT was one of the basic tools that I used and a lot of researchers used. When all the data that are appearing in different velocities and veracities and in the time domain, it makes very little sense. So you have to invert it into the frequency domain. Then you start to understand the patterns and how they work and what clicks and what doesn't and what specific muscle fibers are firing at what frequencies. That gives you a very different perspective. So thinking in terms of frequency rather than time. That's the kind of transformations needed to understand messiness. So a wicked problem cannot be brute force solved. It has to be solved, resolved, and dissolved at once. So if you hear people saying, let's go solve a wicked problem, which means they're treating a wicked problem as a hard problem and just addressing that narrow facet of it. So that's why you have to do all three things, which takes us far beyond the standard territory of engineering. Engineers are really good at the problem solving and how do you improve the resolving and the dissolving part? And that's where scholars like you and so many others come into the picture to provide guidance to our thinking here. So that's the basic idea of wickedness.
Yeah, I think this is connected. I wanted to ask you, like, I'm sure you've bumped into this before in kind of the STS worlds, broadly construed. There's like this long-running critique of like what's called sometimes called the technological fix, sometimes called solutionism, which is I don't know, it's like it's one of these things that's like probably made sense when it started, but then it gets broadened out and applied in all these places, and it stops making sense or something. But I think like a lot of times it's kind of construed as applying kind of like narrow technical conceptions of problem solving to problems that are very deep and big and political, right? And require like social change. And it sounds to me, this is part of your picture, is that like, if hard problems can be solved, but these bigger problems, they can't really be solved. So like taking that kind of problem solving approach is not going to work. Is that what I hear you saying?
That's correct. I think we need to evolve. I was trained as a Newtonian when I was a controls guy. But then I think my graduate education and subsequent learnings on my own made me into a Darwinian. So which made enormous sense because I am a biomedical engineer. That's where my professional degrees are. But now I feel like, and I give enormous credit to a close friend of mine who has given me this kind of framing here. How I moved from a Newtonian to a Darwinian to now I increasingly rely on insights of Isaiah Berlin. I mean, like, so you bring in the three things, they're very different forms and they can coexist. And oftentimes I wish the kind of the Berlin universe was conducive to Newtonian solutions. Who wouldn't want that, right? I mean, like, just click something and things happen. And I think the technological fixes or technical fixes, there are sometimes, and I can see both perspectives here. And I have a lot of friends who deeply believe in the doctrine of technical fixes. What more do you need? The conversations are very interesting, and they're usually short.
Yeah.
But then the other side is like the people who go beyond it. There are many issues that could be, if there is policy will, could be effectively addressed through these hard solutions or the technical fixes.
Right.
And those are easy wins, but we just don't let them happen for whatever reasons.
Yeah.
That's where a hard problem becomes a soft problem with economic incentives and so forth. But you're right. I fall somewhere in between the kind of the extremes here. There are things that I wish I could just blow it out with a technical fix.
Yeah.
But I'm not able to do.
Yeah. And so, just to be clear for the listeners, I mean, when you bring in Berlin, Isaiah Berlin's this famous philosopher of liberalism and critics of liberalism, and part of his worldview is what was sometimes called value pluralism, right? And that there's no reducibility here, that value pluralism is just part of the world, always going to be that way, that humans are going to have conflicting ends they're trying to achieve and such. That's what am I getting you right?
That's exactly correct.
Okay, right.
That's correct. I mean, there's another recent framing of that idea. Steve Rayner, the late Steve Rayner, wrote about, he called it uncomfortable knowledge. All the things that you let go in terms of a precise, neat, shiny explanation.
Yeah.
That's what it is. And we don't let them go because they don't fall into your solution space here. But I think those are some things that we maybe not be ready to engage with.
Yeah.
We might not want to look at. So in a way, and we set them aside. I don't know whether it is deliberately or dismissively, whatever. I think people depends on the person who's dealing with it. I think that's what it is. I've gotten increasingly comfortable dealing with uncomfortable knowledge.
Mm-hmm, mm-hmm. Yeah, and like one place. I mean, first of all, I teach value pluralism kind of in my social science methods classes because I think it's really important to have as a perspective of why we need methods to go out and study what other people think who are not like us. But the other thing I was going to say. Just to relate these kind of soft versus hard problems issues, my example is housing right now, right? So we built fewer houses in the last decade than in any previous decade. It's a product of the 2008 financial crisis you're talking about earlier. We just stopped building houses. Building houses is not magic. We know how to do that. We could, if we wanted to build a lot of houses, we could pass federal money to build a lot of houses and solve supply and demand issues. But right, it's not a technical problem. It's this deeper values soft problem, right? It's about incentives and how our politics work today. This is is that a good example of the kind of
That's a very good example.
Yeah.
And there's several more everywhere. I mean, how do you pay for public utilities, or whether you're a government buying paper clips or battleships, whatever, everything. It's everywhere.
Yeah, beautiful. So you have 6 attributes you trace through the book. There's efficiency, vagueness, vulnerability, safety, maintenance, and resilience. So how did you kind of arrive at these 6? Do you think of them as a taxonomy of sorts, or what are these 6, and what are their kind of, how do they relate to each other?
Correct. This required quite a bit of work on my side here. Let's start with efficiency here, and again, it goes back to my Newtonian origins. Efficiency was often the destination for me. That was what I was taught to aim for, strive for, perfect my approaches.
Yeah.
And I believe that helped me at that stage.
Okay,
so my question was, okay, there was Guru of the past who always aimed for efficiency. That was his final goal. What if I made that as a starting point? Where else would I go? Was the question. Which means, what are all the optional, neglected, discarded ideas that are out there that could usefully inform my approach here. So efficiency as a starting point makes good sense. Who wants to be in an inefficient system, right? I mean, we are all creatures of efficiency.
Yeah.
And engineering, especially as a notable instrument of efficiency, it has given us everything. The way you and I are speaking right now, and the way listeners are probably going to listen to us right now, these are all products of efficiency.
Sure.
We should be thankful
Absolutely.
for. Now, even within efficiency, there's the hard efficiency, right? I mean, where you can realize certain goals. You can then you can kind of waver around a desired objective without hitting the optimal, however defined, depending on one's thing. And then similarly, how do you deal with the value systems? And now that's something efficiency as a concept starts to crumble. It has no roots there. That's when I thought, okay, you need to add more dimensions to it. So I brought in a second element. It was the way I was thinking about it is like solving 6 simultaneous equations, so to speak, mathematically. So what would work well? How is X interacting with Z, and so forth? So I brought in the idea that the things that systems engineers often engage in, try to rework some of them for a broader cultural understanding. The second one is vagueness. And what I was taught in the kind of the Newtonian arena was uncertainty analysis.
Okay,
right. You go, but excessive quantification can lead you to a greater amount of clarity, and you can block and tackle whatever the application is.
Yep.
And this is where I tried to bring in some richer dimensions from philosophy. And I think the broader concept and construct of vagueness makes greater sense, whether it's hard, soft, or messy vagueness, and how they interact to produce wicked vagueness. The third one is vulnerability. And again, it is a broader, expanded perspective on what I was taught earlier, risk management. Do all the things, quantify risks as much as possible. And it made enormous sense, whether it's a capital business
helpful.
or so I think aerospace is just a fantastic example for risk management. So I think that I took a more expanded perspective, because the way you think about human disease, for example, and this goes back to the differences between the doctors and the nurses who taught me and how they thought about risk. And I think the nurses often incorporated the concepts of vulnerability in their dialogues, so forth. So vulnerability is the third one. The fourth one is just brute force safety. And I think that is something, it's a kind of a default human desire. We all want to be safe in some form or fashion, however defined. So I think safety is an integral concept here. But safety, again, you start asking questions whether how safe is safe enough, and you bring in the subjective judgments of then safety starts to become more interesting. It's not as clear cut as buckling your seatbelt, but something more than that. I mean, how do you run safety tests for nuclear reactors? There are actually regulations that require 1 billion hours of testing to demonstrate safety in a nuclear reactor. 1 billion hours, which translates to 114,000 years. Now, how is this humanly possible is a question. And that's where you have all these engineering tools and techniques that come into play that allow us to produce these extremely safe transportation systems, for example. Then comes maintenance, which is a subject that you and Andy Russell have significantly informed me on. And you can see where I think that confluenced very well with my own journey, and something that is so critical but so neglected in society. So what does a hard maintenance look like? What does a soft and what does a messy maintenance look like? And also going back to the religious origins of the concept of maintenance. And that's something that I try to attach it with my own upbringing, with my Hindu upbringing, and see how it is. My grandfather was a temple priest, and we used to renovate our temples every so often years. And that was all religiously sanctioned forms of maintenance, culturally accepted, appreciated. And so it is written into our scriptures. but not necessarily into the modern policy agenda, so to speak. So that's something that I'm trying to play with.
Mm-hmm.
The final one, I think, if you make resilience, which is such an overused word, and if you look at the technical origins of that concept, even the very first time it was used, I think it was used in the French contract law or something like that. But materially speaking, and in this case, literally, it comes from carpentry. It's looking at the stress and strain relationship of specific wood and what they could be used for, whether it's building a cabinet or a ship, so to speak. But the foundations of resilience are also captured in the scriptures way earlier, especially in the Hindu scriptures. But I think every religion has a version of that. But somehow we have gotten confused about it, and we often very simplistically connote it to elasticity, and whether it is like whether you're a medical resident in an emergency room, you have to be resilient to put all these hours. And then now we're looking at even the concept of what is a modern notion of work after COVID. We are still battling it, and resilience comes and goes as in when needed. So I think it's everywhere, omnipresent, but utterly confused. So if you make resilience as the final attribute, how does it make sense? So these are not straightforward, simple, and clear-cut concepts, but together they make great sense as a package. So which means if you filter a wicked problem through these 6 layers, your understanding of the world, stated from a systems engineering perspective, I think is deeper, perhaps more profound. And then you probably think about solutions, resolutions, and dissolutions in a very different way.
Yeah, and it sounds like not just taking a wicked problem through these kind of 6 different lenses, filters, but like Berlinizing them too, right? Like taking in the value pluralism. It really kind of blows out these. It's funny to I see the logic ever more as you kind of talk through it of like taking these things that seem like core engineering values, sometimes reframed from like uncertainty to vagueness as an example, but then kind of like blowing them out and showing like all this other layers of richness. It's cool, man.
And I believe engineering students, the ones that I've met and all the lectures that I give in colleges and so forth, they are capable for this kind of broader understanding. And I sometimes feel it's just a private feeling. It's like, are we over reducing them in some way? And I think maybe it's also generational. I'm older than when I learned all these concepts, but the students are exposed to far more complexity than I was. So I think that's what I thought. Educationally, I think we're ready for Berlinizing for the engineering training paradigm here from the Newtonian approach.
I don't know, man, though. I've determined that revising engineering curricula is not one of my life goals after watching like several of my friends like get dashed upon those rocks. I mean, it's just so hard, unfortunately.
And that's why strategically, I don't deal with curriculum anymore, and that's I think the value of independence that I have. But I think I'm more focused on competencies per se. Right? I mean, like, you've got to be competent in understanding the world through an efficiency framework and a resilience framework and a maintenance framework. Let's not forget it. So that's what I'm trying to do here. Curriculums come and go; they may or may not change. But competencies, I think you have to.
Yeah, those are always
you have to be sincere too.
So what's up next? What's next for you? You got this thing called the New York Trilogy on Maintenance. I think the 3rd piece is coming out. It's 3 pieces you've written for issues in science and technology, right?
That's correct. So I decided to make it into a trilogy now because after I wrote the first one, it immediately prompted me to come up with another one. So the 3rd one I've taken some time to produce, and I'll describe them in sequence here. The first one, I kind of braggadociously called it the greatest show on earth, to illustrate the value and the deeper significance of maintenance and why we need to be celebrating it, and why maybe some tools of showmanship could be useful to present the value of maintenance to the broader society. So I use the example of Otis, Elisha Graves Otis, who developed the elevator safety brake that made modern skyscraper and the modern city possible.
Yeah.
And I use that as an example as a genuine innovation that has altered and safeguarded our lives since then. And but as you know well, genuine innovations are frequently confused with the talk surrounding it, the chatter around it, and how the empty talk around innovation often infiltrates the policy agenda, and how we need to be careful of that. So that's something that I used as the setup to describe why we need some showmanship to do this. That explains the story. The second one, a slight variation, looked at from a different angle, looking at some of the large socially supported, socially sanctioned projects that engineering is involved in. What's in the trade is called a mega project, often $1 billion or more, and some other definitions there, like any project that involves tens of thousands of people or different time zones, whatever, defined differently. But I think the basic idea is utterly large engineering projects. How do you deliver on them and responsibly, equitably, and promptly? And I think that's what mega projects are notorious about. They have schedule overruns, cost overruns at the expense of someone else. So I use that as the problem statement, and looked at what it took to build bridges in the 1920s and 30s and the 40s across New York City. And there's a fabulous, mind-blowingly creative engineer, Atmar Aman, who designed several of them. I think 8 of the current bridges in New York City were designed by them. I mean, designing a bridge on paper itself is an accomplishment these days, but building them and seeing them for over a century. And these are not ordinary ones. We're talking about like George Washington Bridge, Verrazano Bridge, and it's just utterly amazing accomplishment. Yet we don't talk about individuals. So I've taken people who we have forgotten about. I think I wanted to kind of use them as inspiration to guide these tales. So back then, when Aman built one of his bridges, and I talk about the Bayonne Bridge, which he did, there were no environmental reviews or getting stakeholder feedback and so forth. And to retrofit it recently to increase the height of the span so they could allow bigger sized container ships, cruise ships even, to go through them. So it required some retrofitting project, and that took several years. I mean, just the environmental review alone cost multiple millions of dollars over many years and so forth. So too often we get carried away by the grand notions in engineering. It has to be the big, bold, and whatnot. Of course, we all love that. It's inspiring, and it used to be a product of the message as well. But I changed one letter, one vowel in what has come to capture as grand challenges, the kind of the big visionary thoughts that keep the society going. I changed one letter and came up with grind challenges, which completely changes the entire meaning, which is what modern engineering is all about. The interlocking, vexing stuff. So that article just squarely took me into the realm of a friend of mine described that I'm no longer interested in the sexy, but only the vexy parts of engineering. So there you go. I think he captured it correctly. So the grind challenges framework and how bulk of maintenance, the way we care for society, conserve and renew our society, are all tied to that. It is such a difficult part. No one wants to do it, yet it's important. So it's not something that we proudly display on our resume, so to speak. And I think that's what I wanted to do with the second one. So that was the second piece. The third one gets to a much more complex topic. I've spent some time on it. Let's see what comes out of it. It's currently in edit, which relates to how we assign prestige in engineering to certain activities. And I was impressed by a recent paper that looked at the many different activities, standard activities that engineers are involved in day in and day out. Hasn't changed in a while. Of which innovation, research, and development is just one of them. I'm thinking in a spectrum of like over a dozen activities. So only a minority, a tiny fraction of engineers are involved in innovation and R&D, and the rest of them are doing the kind of thankless, unglorious, unthanked work that keeps the world running or prevents it from crumbling. And that's what I wanted to articulate. Of course, you have argued about it too, but from an engineering angle, how did we get into the talking point of celebrating, highlighting only the innovative notions of engineering? Now that's a political statement, and it requires us to probe the politics of recognition in engineering, and that's where I'm going with this piece.
That's cool, man.
So the central character, giving part of the clue here, the central character of this piece is related to Central Park in New York, and how one person gets the credit and the other one is completely forgotten, ignored, and so much so to the point that he ends up going after seeking prestige for the lost glory that he was inflicted on and what he does to it. So it's a very entertaining story to the point that why haven't we heard of this guy before? So that's how I want to conclude this series.
Cool. Yeah, I think this prestige thing is a real problem for education, because we hook engineering students on, you can be like Elon, robot competitions, all this like super fun design stuff, as if that's the core of engineering. And then, they end up being like a quality engineer in a potato chip factory or something, which is important, right? Because I want my potato chips to be crispy and I want them to be, not kill me with bacteria. I mean, it's very societally important, but is not the kind of stuff that gets a lot of recognition. So I think it's hard on students. I think it's worse in architecture, where, like students get trained, it's all like Mies and Corbusier and all these characters. And then like they go on these terribly boring, like jobs doing like building code management and crap like that. But, I think there's a real disconnect between how we hook students and what they're going to do. And I feel like, if we could talk about these things in a little bit more holistic fashion, there might not be so much kind of schizoid experience.
It takes us back to where we started the conversation. How I was originally hooked to engineering as this is a problem-solving profession. This is it, and who wouldn't be inspired by that? I mean, and I think we still are facing that, and I think engineering is much more than problem solving. It always has been, yet we relentlessly focus on that part. And also kind of amplify an aspect of engineering that only a tiny fraction of the people do, however valuable it is.
Totally.
And I think we're doing a disservice to what the profession is. And I think we need to have a sincere conversation, if not reflection, on what the underlying politics of recognition is. And that goes to, based on the conversation here, not just the people we recognize, but also the problems we recognize. It goes back to the hard, soft, and messy things. We often focus on the easy victories attained by hard solutions, and then boom. And something is going on there, and I think we are capable of being sophisticated here. And I do have that trust, and I'm hoping that we will get there.
Well, Guru, this was a lot of fun, just like I knew it would be. I hope people check out your book and your many coming articles, no doubt. Thank you so much for taking the time to talk to me today, buddy.
Lee, absolutely a pleasure. Thank you. And once again to the listeners.
I hope you enjoyed this episode of our podcast. You can reach us with questions, comments, and suggestions at leevinsel@gmail.com or by following me on Twitter at STS_news, or on YouTube at People's Things. Our podcast is distributed by the New Books Network, the leading platform for academic podcasts, so that you can find us wherever you get your podcasts. People's and Things, like most things in this world, depends on the work of many people. I want to thank my brother Jake Vinsel for writing the music for the show. I want to thank my buddy Juliana Castro for designing the logos for the podcast. You can check out her work at julianacastro.co. Joe Fort is the producer for the podcast, and Mandy Lamb is the production assistant. This podcast and other Peoples and Things programming are produced in affiliation with Virginia Tech Publishing and supported by the Center for Humanities and the University Libraries at Virginia Tech. For information about other podcasts from Virginia Tech Publishing, visit publishing.vt.edu. For the entire Peoples and Things team, I am Lee Vinsel. And most importantly, I want to thank you for listening. Thanks.